Hi, I'm Professor Angela Rasmussen from the Department of Electrical and Computer Engineering at the University of Utah. Today I wanted to go over a DC analysis of a circuit that has a capacitor in it. So the goal of this is to analyze a circuit that has a capacitor in it when we have a DC source. So we see here that we have a circuit before a switch is opened and that it has been sitting in a long time. So we first want to start this by opening up the capacitor. So when we open up the capacitor, we see that is also the voltage across R4. So we see that is the same voltage as across R4. So if we find the current going through R4, we can find, using Ohm's law, that voltage VC. And we see that the current I there, we know that the voltage here is 6, so using Ohm's law, it's 6 divided by 3K, which gives us 2 milliamps. And then VC has the same polarity as the current, and so that will be a positive I times 1K to give a value of 2 volts. So this will be our initial value for VC. We want to find 3 components: the initial value, the final value, and tau. So the next step will be to find the final value. We're going to use the same circuit, except for this is the circuit when the switch now is opened, and it's again been sitting for a long time. So if you can't remember if you open or close a capacitor after a long time, remember the impedance in the frequency domain is minus j over omega c. For DC, omega is always 0. And so when we have a minus j over 0, that is going to go to infinity, which looks like an open. So that is one way to remember open or closed. So for this circuit, we see that this is a dangling wire over here. So the current is going to be 0 here. If that's the case, the voltage on this side is 6, the voltage on this side is 0, and so VC is going to be 6 minus 0 to give 6 volts for a final value. The last component we need to find is tau. And for tau, remember that we always use the final circuit. So we are going to label the nodes A to B around where the element is going to be, and this is the same for inductors. We only have independent sources, so we're going to short the independent source and look at the pathway between A back to B. And we see that there's only one resistor there of R5, so RTH is going to be 2K. Tau for a capacitor is equal to RTH times C. And so in this case, our C was given, which I deleted. Our C was given as 1 nano. And so we're going to get 2 microseconds for our tau. And so that is our value for tau. Now we can plug this into the final equation, or the general form equation, for VC of t. And remember, the equation is final plus the initial minus final e to minus t over tau. So our final in this case is 6 volts. Our initial is, or was 2 volts. So we use 2 minus 6, e to the minus t over 2 micro. And that's in volts. And that is our expression for Vc of t. And that concludes this example. Thank you for watching.